Let's try to solve this question. Find f prime of x of f of x equals x minus 1 over x using first principles. First principles, otherwise known as the definition of the derivative, is f prime of x is equal to limit as h approaches 0 of f of x plus h minus f of x over h. The idea is that we place x plus h wherever we have x in the equation. We substitute f of x plus h, we also substitute f of x, and we put h, simplify everything, and that's how we get our f prime of x. With that in mind, let's get into it. Okay, we have our f of x is equal to x minus 1 over x. What we want to do is make these a single fraction, so that becomes x in the denominator, 1 into x times x, that's x squared, minus x into x, that's 1 times 1, that's 1. So this is our f of x. Now our f of x plus h, we put x plus h wherever we have x in the equation. So this becomes x plus h squared minus 1 over x plus h. If we expand x plus h squared, it becomes x squared plus 2xh plus h squared minus 1 over x plus h. Now, x plus h squared is the same as x plus h multiplied by x plus h. So by the FOIL method, x multiplied by x, that's x squared, x again multiplied by h, that's xh, h multiplied by x, xh, h again multiplied by h, that's h squared. So this becomes x squared. These two are like terms. When we add them, we get 2xh plus h squared. That's how we got this result. Then this is minus 1 from the previous step. Now, let's go ahead and plug in f of x plus h and our f of x. So this is limit as h approaches 0. Our f of x plus h is x squared plus 2xh plus h squared minus 1 over x plus h. This is our f of x plus h minus our f of x is x squared minus 1 over x. This entire thing is being divided by h. Now, what we want to do is simplify both fractions and make them a single fraction. Before we go on, the reason for simplifying all these steps is because if we plug in h into the limit, it will have division by 0. It will be the numerator divided by 0, and division by 0 is undefined. So that's why we have to simplify so that h is no longer in the denominator. All right, and so that it's not division by 0. So we have limit as h approaches 0. Simplifying the numerator, we have x plus h plus 2xh plus h squared minus 1 over x plus h minus x squared minus 1 over x. This entire thing is divided by h. So let's simplify this now. our common denominator has to be x plus h, and from this side it's x. So x plus h into the denominator, we remain with x. Then open brackets, multiplied by x squared plus 2xh plus h squared minus 1 minus x into this denominator. We have x plus h multiplied by x squared minus 1. This entire thing again divided by h. Now let's simplify the top part. Now we remember this is limit as h approaches 0. Simplifying the numerator, x multiplied by each term in the brackets, this becomes x cubed, x multiplied by 2xh, that's 2x squared h, x again multiplied by h squared, this is x h squared, and x multiplied by -1, that's minus x. Now let's get to this other side. Let's keep the negative firstly, and then we expand these two brackets. So x and x squared becomes x cubed becomes -x. H and x squared, that's plus x squared h, and h and -h becomes -h. This entire thing is over x plus h and x, and the whole thing all together is divided by h. Limit as h approaches 0. Now let's open brackets. X cubed plus 2x squared h plus x h squared minus x. Here we get negative x cubed, negative and negative x, that's plus x, negative and x squared h, that's minus x squared h, negative and negative h, that's plus h. This entire thing divided by x plus h and x, and the whole thing all together divided by h. Limit h approaches 0. Now, at this point, we have to cancel out like terms. So we have x cubed here, and we have negative x cubed. So these two cancel. We have negative x here, and we have plus x here. So these two as well cancel. What else can we cancel out? We have, well, we can't cancel this one, but we have 2x squared h, and we have negative x squared h, so we can put them together. These two become x squared h. What else? We have x and h squared. This one is alone, so it remains as x h squared, and then we also have h, which is left. This entire thing is over x plus h multiplied by x all together divided by h. Limit as h approaches 0. Now we simplify this divided by h. So this becomes limit h approaches 0, x squared h plus x h squared plus h over x plus h and x. This is division, so it becomes multiplied by 1 over h. So we have limit h approaches 0 of x squared h plus x h squared plus h over xh x plus h. Now, to cancel h in the denominator, we have to make sure we factorize the top part, the numerator. So if we factorize the numerator, it will be h, open brackets, x squared plus, here we're left with xh, and at the end here, simply 1. And then we'll have x, xh, x plus h. Limit h approaches 0. Now that we have this, h and h here can cancel out, leaving us with x squared plus xh plus 1 over x plus h and x here. This is limit as h approaches 0. Now, we still have h in the denominator here, but notice that this h doesn't cause division by 0. So we are fine to apply the limit. So here we simply say when h approaches 0, we plug in 0 wherever we have h. So this becomes x squared plus x 0 plus 1 over x, open brackets, x plus 0. This becomes x squared plus 0 plus 1 over x multiplied by x. So this finally becomes x squared plus 1 over x squared. And that is our f prime of x.